Okay, we will begin the class. The last class, what did we discuss? Just refresh the things now.
Ma'am, we discussed the Thevenin's theorem.
Yes, we have discussed problems based upon Thevenin's theorem.
Yes,
Today's
ma'am.
class, we are going to discuss the remaining theorems that are included in your syllabus. That is Norton's theorem, maximum power transfer theorem, and superposition theorem. Now, as I already told in previous class, Norton's is dual of Thevenin's theorem. So, what do you mean by Thevenin's equivalent?
Ma'am, the voltage source is connected in series
Yes,
with the
Thevenin's
R Thevenin.
equivalent means suppose if you are having a voltage source connected in series with your R Thevenin, then that will be called as your Thevenin's. But when it comes to this Norton's equivalent, just it's the dual, you can see one diagram that is being represented here. So what does it have? What are the elements that it is having?
Current source.
One current source. How is it in connection with that resistance? Thevenin's
Parallel,
resistance
ma'am.
again.
Parallel.
Parallel. So this circuit will be called as what circuit?
Norton's equivalent.
Norton's equivalent
Resistance.
circuit. And earlier case you are having one formula for IL. Okay, for Thevenin's what was the formula for IL?
V Thevenin upon R
IL
Thevenin
was
plus RL.
equivalent to V Thevenin divided by R Thevenin plus RL. But for Norton's the formula will be changing a little bit. IL will be now equivalent to ISC into R Thevenin divided by R Thevenin plus RL. Okay. ISC is also denoted as IN, Norton's current. Okay, our ISC is a short circuit current. So what is the formula for IL as per Norton's theorem?
ISC into R Thevenin by R Thevenin plus RL.
Yes, there is a formula here again. Okay, that formula is for determining the load current when it comes to Norton's theorem. Okay, now we'll move on to the problem section. Take down the problem. They have asked you to determine what as per this problem. You have to determine what. Read the problem statement.
Determine the voltage source voltage across the 200 ohms resistor in circuit by Norton's theorem.
So we are to find out the voltage across this 200 ohm resistance VAB. You are to find out by using Norton's theorem. Okay, that is the problem that is given in the paper. Now how to proceed I will tell you. Now if we are discussing about Thevenin's equivalent means the first step that you will do is you will open that particular terminal. But this is your Norton's theorem where you will be finding out short circuit current. So what you will do with that terminal? Come on, this is the terminal that is concerned. Okay, if it is Thevenin's means you will open. But here they have asked you to proceed with Norton's theorem which is relevant to ISC. So what will you do? Instead of opening, you need to do what with that terminal?
Ma'am, short the terminal.
Short. Okay, you need to short it. First step is you need to short it. Okay, then you will be finding out ISC into that. Okay, that will be your first step.
Ma'am, there is a
Okay.
lot of disturbance from your side.
Okay, now it's okay. Yeah? Still it's not okay. Is it okay?
No, ma'am.
No, ma'am. So either I'm getting yes.
Wait, wait. Now okay? Now is it okay?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, now I have to short this particular terminal. Then I have to find out the current ISC. So how to proceed in finding out ISC? That is the thing that I have to find it out. So how can I find it? This is a simple problem. Can you think of any way in which you will be able to find out that current through that branch? Here you are having a 10 volt source which is connected in series with 50 ohm. Okay, so if you are using Ohm's law, you can find out the current. What is the current? What will be the current? V is equal to 10 and R is equivalent to 50 ohms. So you can find out the current V divided by R. So that will be equivalent to 10 divided by 50. So what will be the current?
0.5.
0.2.
And 0.2.
1.2.
0.2. Okay, that much current is flowing here, 0.2. From this side, there is a 0.2 ampere flowing. Okay, but the same way you need to find out the current flowing from this side also. Both these things, if you are summing up, you will be able to find out the current through this particular terminal AB. So what current is flowing here?
1.2 men total.
From the other
1
side,
ampere.
what current is flowing?
1
So here you are
1
having
ampere.
1 ampere. Here you are having 2.2 ampere. So what will be the current flowing here? Okay, now tell
Ma'am,
me what will be the
1.2
ISC
ampere.
current that is flowing through that IAB branch now. You need to just sum both. Okay, so that current will be 1.2 ampere. That is your ISC or Norton's current. Okay, so first step Norton's current, that is over. Next thing is, as usual procedure, you need to find out what is your R-Thevenin. So you know how to find out R-Thevenin. You have to kill the sources. So what do you mean by killing the sources?
Voltage short circuit, ma'am. Current.
And we have to
So there is a
open.
voltage source. You have to short it, short the voltage source, short circuit. And in the other side,
Okay.
you are having current source. This you will be opening. Okay,
Open.
this you will be opening. Like this you will open and you will redraw the circuit and you will find out R-Thevenin. Okay, so this is how I have redrawn the circuit. Here I was having that voltage source that is being shorted here. And in this side I was having one current source that I have opened. Okay, if I am redrawing the circuit, this will be the circuit that I will be having. Okay, now across what terminal I want to find out R-Thevenin? This is the
What was the
branch,
Two.
question?
isn't it? Where I will be finding R-Thevenin across what branch?
AB.
AB branch only, no.
AB, ma'am.
So this is my A branch, this is my B branch. Okay, here only I need to find out the R-Thevenin. Okay, so I need not consider this 20 ohm. Okay, so only the 50 ohm should be considered. That will be taken as my R-Thevenin value. Okay, so I have found out ISC which is equivalent to 1.2 ampere. R-Thevenin is found to be equivalent to 50 ohm. Just I need to find out IL. So what is the formula for IL that you already know? What is the formula for IL?
IAC into R-Thevenin by R-Thevenin
Divided
plus
by
RL.
R-Thevenin plus RL. So ISC is equivalent to 1.2. R-Thevenin is equivalent to 50. So 50 divided by what is the value of AB resistance? 10 ohm or 20 ohm?
20. 20.
20. So tell me what is IL value finally. That is what is asked in the problem. So what is IL value? 1.2 into 50 divided by 70.
Ma'am, 0.85 ampere.
0.857.
0.85. So you're telling 0.85. Let us check that out. The answer. Ohm or 20 ohm AB resistance, sir.
Ma'am, it should be 200, no?
I think 200 ohm they have given a problem.
Yes, ma'am, they have
Yes,
given
ma'am.
200.
That is 200. No, why you people are telling 20 ohm? Okay, that is a
Sorry,
200
ma'am.
ohm value. So now what is I 7.2 into 50 divided by 50 plus 200? Replacing the 220 by 200.
Ma'am, it is 0.24 ampere now.
0.24 you are getting a
Yes, ma'am. It is in
yes,
amperes.
0.24 is the answer. Okay, all right. That is indicated
Ma'am,
here.
will you
So
please
this solves the
explain the R
problem.
Thevenin?
This is a simple problem. Okay, all right.
Ma'am,
0.24 ampere is the answer. Okay. Now next.
ma'am, will you please explain the R, how you got R
Okay.
Thevenin?
So this is across which you are having 200 ohm. No terminals.
Yes, ma'am. AB.
Okay. AB that you are opening. All right. So between these terminal only I need to find out RThevenin. Okay. So I have shorted this current source, I have opened this voltage source. I need not consider this 20 ohm because I am looking back from the terminals A and B only. Understood? Yashwant.
Okay, ma'am. Yes, ma'am.
That is how I am not considering 20. Only 50 ohm I am considering it to be RThevenin. Okay.
Okay, ma'am. So we have to consider the resistor which is equivalent to that voltage source.
Yes, across this terminal only I want RThevenin, not after that.
Okay,
Okay.
ma'am.
By looking
Okay,
back
okay.
only I want to determine RThevenin. Okay.
Okay, ma'am. Thank you, ma'am.
Okay, one more simple problem we'll discuss on this one. So let's discuss this problem. This problem they have made one simple simplification that you need to know. So what is being asked in the problem? You are to obtain Norton's equivalent circuit for the following figure. That is the question. Now they say that there is the voltage source here which they are considering to be an ideal quantity. Okay, and across which what resistances are connected? There is a 100 voltage source which is assumed to be a very ideal one. Okay, but it is connected in parallel across two values of resistors. What are the two values of resistors that are connected in parallel?
1020.
10 ohm and 20 ohm are connected exactly in parallel with that ideal voltage source. So since all are connected in parallel, they are saying that safely you can remove it because the same voltage will be existing here also. Okay, you can remove that resistances and you can draw the circuit again by eliminating them. Okay, then also there won't be any change across or in the original circuit. Okay, that is the basic understanding of the concept. Are you able to grasp the concept that I am telling you?
Yes, ma'am.
Yes, ma'am.
See, the
Ma'am,
No,
thing
ma'am.
is, here they are assuming this 100 volt to be an ideal voltage source, ideal element. Okay, perfect element. So they are saying that there are two parallel values of resistances, all are connected in parallel. So you know whenever there is a parallel combination, the voltage sources will be equivalent or they are differing.
Ma'am, equal.
Equal.
Equal. So by that concept, it will not be a problem if you are removing this 10 ohm and 20 ohm. Only if you are retaining 100 volt, then also there won't be any change significant that is happening in the circuit. So in order to make the calculations more simple and you opt in order to obtain the Norton's equivalent, they are eliminating the 10 ohm and 20 ohm from the circuit. Okay, this you can do. Suppose if by chance some combinations are coming like this in different problems, then you can use this concept to simplify the circuit. Understood? Understood or not?
Yes,
Yes,
ma'am.
ma'am.
This is a simple concept, okay. They are having parallel combinations, so whenever it comes to parallel combination of elements, the voltage will be always the same. So that concept makes way for the elimination of 10 ohm and 20 ohm from the circuit, and if you do so, the circuit will become easy to further solve it. That's all. Okay. So after eliminating this 10 ohm and 20 ohm, they have redrawn the circuit like this. Okay, this circuit. Here you are having one 10 ohm and 20 ohm that they have removed, okay, and they have redrawn the circuit. Now, how can you proceed for finding out IN and RThevenin? Tell me. I want currents AB, okay. So I'll be shorting it. I want to find out ISC. So what law can I apply? Easy one.
Ma'am, KVL.
As KVL or network reduction I can use, okay, any method. So if I am using KVL means I can assume two mesh currents, then I can write matrix and I can find out I2. If I find out I2, that will be equivalent to what value?
ISC.
ISC.
ISC. Okay, that is the easy method. Let us see what they have did it. Okay, see. Same way they are also trying to solve. So I am assuming two currents here, I1, I2. If I am able to find out I2, then it will be equivalent to ISC. That's the thing here. So what will be the mesh equation? V is equal to IR matrix I need to write. So what is the voltage matrix that I will have? Here one voltage source is there, here one voltage source is there. Both are in opposing connections. So 100 minus 50 I will get for the first mesh. For the second mesh, 50 I will be getting. So this will finish off the voltage matrix, and I1 and I2 are the unknown currents that I want to determine. That is the X factor. Now what is R11, what is R12, what is R21 and what is R22? That is resistance matrix. Whatever may be the sum of the resistances in the first mesh, what is the value?
10, ma'am. That is R11.
10. There is a 5 ohm, sum it up, that 10 ohm is present here. Then which value of resistance is common between
Ma'am,
first
5.
mesh and second mesh? 5 is common, so give it a negative sign, so minus 5. Similarly, R21 is also same, minus 5, the common value of resistance between the two mesh. Now when it comes to R22, the sum of resistances that are present in the second mesh, so what is the sum?
7.
5 plus
7. Okay, 5 ohm, 2 ohm, you sum it up, that's 7 you write here. Then by applying Kramer's rule, you need to find out del, that is 10 minus 5, 7. You find del and then del 2. I need not find the del 1 because that current is not needed. Only I2 is enough for me. So directly I can go for finding del 2. How can I find out del 2? The second column I am going to replace by the voltage element, then find del 2. Then I2 or ISC current will be equivalent to del 2 divided by del. So find this and tell me the answer. What is I2?
Ma'am, 16.66 ampere. I2.
All have got 16.66 ampere.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
16.66. Let us check the answer. Okay, so 16.67 ampere is your Norton's current or ISC. Now, one more thing you need to find out, that is you need to find out RThevenin. So by adopting the usual procedure, you have to kill the sources. So how will you kill the sources? What are the various sources that are present here in the circuit diagram?
Ma'am, two voltage sources.
What are the various sources that are present in the circuit diagram?
Ma'am, two voltage sources.
Two voltage sources. So whenever there are voltage sources, you have to short it or open.
Short.
Short.
Yes, two voltage sources, you have to short it or open.
Short it, ma'am.
Shorted, ma'am.
Short it. Okay, so you short it. This also you short it and you redraw. Okay, you have to redraw again, and then by looking back from AB, you need to find out the equivalent resistance. So there was one voltage source here that they have shorted, and here also there was one voltage source that they have shorted. And now tell me what is your RThevenin by making equivalence by looking back from AB.
Ma'am,
5 into 5. 5 and 5 are in parallel. Okay, plus 2. So what is the answer?
four two.
5 and 5 are in parallel. So 5 into 5 divided by 5 plus 5 plus 2. So what's the answer? What is your
4.5.
RThevenin?
4.5.
4.5 ohm.
4.5. Let's check 4.5 you say. Okay, 4.5. Alright? So this circuit is called as what circuit?
Norton's equivalent.
Norton's equivalent.
Yes, Norton's circuit, Norton's equivalent circuit where the short circuit current is 16.67 and RThevenin is equal to 4.5. Okay. So next problem. The next problem is also of the same pattern only. So I am skipping that problem. So now we will see one Wheatstone bridge problem. What does this problem say? There is one circuit that is given which resembles an Wheatstone bridge, and what has been asked? You ought to use what theorem again?
Norton's theorem.
Norton's theorem. To find out what?
Current.
To find out current through?
Current.
Resistance of ammeter.
Current in this AB terminal. Okay, there is an AB terminal across which zero resistance ammeter is connected. That IAB current is being asked by applying Norton's theorem. Okay, so again as usual procedure, what are the steps that you have to follow?
Ma'am, first find ISC current, then RThevenin.
Yes, how will you find out ISC current? First thing is you have to short the terminals across which or through which that parameter is being asked. So what terminals will you short? Through which terminal the current is asked?
Ma'am,
AB.
AB.
AB. So
So
this
we have to
terminal you will
remove.
short first. You
Yes,
will
ma'am.
short this terminal. That is your first step. If it is 7 inch means you will open that. If it is not ans means you will short. Okay. Then you need to find out the current ISC through that particular branch. So again, what law will you apply? The previous problem, what law did you apply?
KVL.
Ma'am,
KVL.
KVL.
So how many meshes are there?
Ma'am, 1.
One now.
Ma'am, because we have removed it.
Two.
AB terminal.
This is first mesh through which you have assumed current I1, first mesh. This is the second mesh through which you have assumed the second current. This is your third mesh through which you have assumed I3 current. So what will give you ISC? IAB is the terminal that is in common connection between what two meshes?
1 and 2.
1 and 2.
1 and 2. So what will be ISC? The currents through these meshes are I1 and I2.
I1
What will
minus
be
I2.
your ISC? I1 minus
I1
I2.
minus I2.
That thing only you have to do by applying again matrix method, direct inspection. So tell me what will be the matrix expression again by using Ohm's law matrix only. So what will be the voltage matrix that you will be having?
0,
In the first
0,
mesh,
20.
yes, 0, 0,
20.
20.
20. Okay, in this mesh, no voltage source. In this mesh also no voltage source. But in the third mesh, you are having 20. When you are following the current, it is going from minus to plus only. So the voltage matrix is 0, 0, 20. Okay, and the currents that are unknown are I1, I2, I3. Okay, and what about R11? Here you need to write R matrix. What is R11? This will be a 3
13.
cross 3 matrix or 2 cross 2?
3 cross 3.
3 cross 3. Okay, so what will be R11? That is the value of the resistances that are present
In mesh
that
1.
are present as a sum in the first mesh. So what is the sum?
13, ma'am.
13 ohm.
13.
5 ohm, 8 ohm. Okay, so what will be the answer?
13.
13. Okay, so R11 is 13. Okay, what about R12?
Ma'am, it is 0.
Is 0. Between these two meshes, there is no common resistance, so 0. So what about R13? Between this mesh
8,
and
ma'am.
this mesh,
8,
8
ma'am.
is common, so that is minus 8. Okay. Then,
R31 is minus 8.
if it comes to, right,
R21.
tell me what is R11? 13, 0, minus
0
8.
minus 8.
Okay. Similarly, what is R21?
0.
0. What is R22? That is all the values of the
And
resistances
7,
7.
we are
7.
summing. 7.
7, ma'am.
7.
And between R2 and 3, what value of resistance is there?
Minus
Minus
Minus 2. Okay. Now in the same way, what is R31?
minus 8.
Minus 8.
minus 8.
Between these two, minus 8. And between these two, minus 2.
3.
And what about R3? 3, 10, na?
10.
Yes, ma'am.
10.
10.
Yes, ma'am.
Okay.
10, ma'am.
10.
10.
Okay. So if you, this is by direct observation. This is a matrix relation that you got. Okay, again you need to find out del and then del 1, del 2. Okay, then I1 minus I2 you need to find. I1 will be equivalent to del 1 by del. I2 will be equivalent to del 2 by del. Okay, this will be the current ISC or IN, not trans current. Tell me what is the answer. Veeravardhan, mute your mic. Come on, Nala, trying to solve.
I'm 2.73 I1. and 1.26 I2.
Ma'am, the whole current by subtracting is
4.73, yeah.
1.47.
All got this answer? Okay, let's check up. What is the current that you told us? Which one is
1.47 ampere.
4.6, Sony?
Ma'am, I was telling I1
I1
and
now.
I2.
Ma'am,
Okay.
I1 is 2.73.
Check out your answers with the answers that are shown in the slide.
Yes, ma'am. Mine was coming 1.47 ampere ISC.
Are you getting this answer? 1.4634. What about the rest?
Yes, ma'am.
And it means
Same 1.4, ma'am.
yes, ma'am. 1.4.
Okay. Sony got something wrong, huh?
No, ma'am, I was telling the value of I1 and I2. When you subtract it, I get 1.47.
I1 also he's telling 1.2. You got 2.
I1 is 2.73, I2 is 1.26.
Yes, ma'am.
When you subtract it, you get.
Okay, you got the answer?
Yes, ma'am.
Yes, ma'am.
All the rest? Okay, good. What about the other people in class? Dhanush, Chinmoy, Srish, Gokul?
Yes, ma'am.
Yes, ma'am.
Sai Pritam is present today? Sai Pritam? No, I'm asking Sai Pritam. His full name is Gangi Reddy only, no? Sai Pritam. And there is a Lakshman Sai in this class. Is he present? Lakshman Sai.
Ma'am.
Okay, but why did you attend the previous classes, Sai Pritam? So many classes you missed, eh? What, ma'am? Who is telling ma'am? Lakshman Sai, ah?
Yes, ma'am.
Lakshman Sai, you accept my invitation for GC. Are you not done it so? Lakshman?
Ma'am.
Will you accept the invitation or not?
Hello, ma'am.
Accept my GCR invitation, man. Still it's pending for you.
Okay, ma'am.
Yes, stop following me and you. Okay, accept. Wait, okay.
Okay, ma'am.
Okay, now all got this answer, ISC. Next, how will you proceed for R-Thevenin? You know the procedure.
Ma'am, we
R-Thevenin, how
will
will you
kill all
solve? R-Thevenin, how will you solve?
Short the source.
Ma'am, kill all the sources. That
Kill
means
voltage
short the
source.
voltage source.
Short the voltage.
Yes, you will kill all the sources. This is the single source that you are having, that you will short it. Okay, then it will leave it open only. This will be open only. Sorry, open or short. Okay, then you will redraw the circuit. Okay, alright. Then if you redraw means which two resistances will be connected in parallel? Or you will remove, I think so, not short. Okay, you will short this only. Okay, so this 5 ohm and 8 ohm, 5 ohm and 2 ohm, between this you will be having that battery that is being shorted, and this A and B, this portion you will remove. Okay, so it will be left open like this only. Okay, so what will be the value of the resistor? This is 5 ohm, 8 ohm, 2 ohm, like this. Always when it comes to R-Thevenin, you open the disconnect that RL value or whichever branch through which you are supposed to find anything, that you have to remove. Okay, that's how this terminals are left open, but it will be still there. Okay, so how will you solve for it? Tell me.
Man, 5 and 5 will be in series, 8 and 2 will be in series, and they both equivalent will be in parallel with each other.
Okay. Alright. So here I have written the circuit. This is a shorted battery, shorted source. Okay. So if you are seeing means this is a 5 ohm. That's a mistake. Alright. So tell me what will be the resistance.
10.
Here this 5 and 5 will be connected in parallel. Okay. Then 8 and 2 will be connected in parallel. So 8, 2 and here 5, 5. Alright. This is a shorted terminal. This terminal is that battery, no? Here battery is present, the shorted terminal. So R Thevenin. Okay. So what is your R Thevenin?
5.45 man.
5.4. 4.1 is the answer. So this is 5 ohm. That is a mistake that they have given. Okay. Now this terminal is a battery shorted.
4.1
Okay.
ma'am.
It's here 8 and 2 and here 5 and 5
Yes ma'am, 4.1 man.
R Thevenin. So tell me what will be the answer.
4.1 man.
4.1 all got 4.1.
Yes ma'am. Yes ma'am.
Yes, ma'am.
4.1. Okay.
Yes ma'am.
4.1. Alright. Then final Thevenin's equivalent, Norton's equivalent they have drawn. Okay. What was the value of ISC? I think 4.1. I really have divided by 6. 4.1, 4.1.
Ma'am, ISC is 1.463 ma'am.
Okay, okay. Wait. Yes, okay. Alright, this one is for 1.46 and 4.1. Okay, and okay, IL is asked in the problem. IL, what is the formula again? ISC into R Thevenin. That I think that is a zero resistance. Zero resistance ammeter they are saying. So 0 plus R Thevenin only. Okay, that's why that RL current is IL is equivalent to ISC. Understood? Yes or no?
Load current is 0 ma'am. Load resistance
That IL value is usually given by the formula ISC R Thevenin divided by R Thevenin plus RL. But it is a zero resistance ammeter. Okay, so this RL is 0.
Yes ma'am.
So R Thevenin gets cancelled and IL is equal to ISC. That's why they have denoted that in the circuit. Okay.
Yes ma'am. Okay ma'am.
Alright, this finishes up the problem. Okay. So this for problems relevant to what theorem? Norton's theorem. So if they ask you to proceed with Norton's theorem, what is the procedure that you will follow? Procedure that should be followed is you need to find out the two parameters. One is short circuit current or Norton's current
First two.
and R Thevenin. So how will you proceed with the ISC? ISC, if you are to proceed, then what is the procedure? Whichever may be the terminal that is being questioned for current or voltage, that you should short or open. Short.
Short.
Okay, then adopting any method, you need to find out the current through that branch. Okay, that is short circuit current or Norton's current, and then you have to find out R Thevenin. So how will you find out R Thevenin?
Volt.
As usual procedure, Voltage source
Voltage
expression
means
means
short circuit, current means
short
open.
circuit, current means open
Short
circuit.
open.
Then you will find out RThevenin. Then finally the formula
Not on sequence.
for IL, you know, that is ISC into RThevenin divided by RThevenin plus RL. That's all.
RThevenin plus
Okay,
RL.
3 steps. Then you should draw the Norton's equivalent. So what is Norton's equivalent circuit finally? Norton's equivalent means one current source in parallel or series with RThevenin.
Parallel.
Parallel. So this circuit is called as what circuit?
Norton's equivalent.
Equivalent.
Norton's equivalent circuit. Okay, now next the remaining two theorems are superposition theorem and maximum power that we'll discuss now. Wait till the page loads, okay. Okay. Alright, I will tell you first what is superposition theorem. Suppose if you are having any circuit, you assume, okay, in that circuit if you are having so many sources like voltage source, current source, if they are present in many number, then you will usually use superposition theorem to find out the current or the voltage across and through any branch. If you want to find it in a linear circuit which is composed of many sources, then the general way to find out the current and voltage is to consider each and every source separately. Okay, individually you consider the source, find out the current or voltage, then you finally sum everything together. Okay, that is why it is called as what theorem? What is the name of the theorem?
Superposition theorem.
Superposition theorem. So first problem says, what do you need to find in the first problem? You have to compute the current in what ohm resistor?
23 ohm.
This 23 ohm through which you need to find out the current. Okay. How many sources are there in the circuit?
Voltage and current source.
Voltage source is there, current source is there. So two number of sources are there. So by superposition theorem, I want to find out the current through this 23 ohm resistor. So what I can do is, I can do this circuit analysis in two different ways. By considering this voltage source alone, okay, as the first case, then I can eliminate this and I can consider only the current source, that is case number 2. In both cases, I will find out the current through I23. So final current will be I23 when I am having this voltage source alone, plus I23 when I am having the current source alone. Understood?
Yes, sir.
Yes, sir.
So that is why it is called a superposition. You know the general meaning of superposition. What is the general meaning of superposition? Okay. What is general meaning of superposition?
And
Superposition means combining or summing. Okay. So superposition theorem means whenever a circuit is having many sources, whenever a linear active network is consisting of many sources, and if you have been asked to find out the current through a particular branch or voltage across a particular branch in such a circuit, okay, then you can first analysis case by case. When you are considering source number 1, Neglect all other sources. Okay, neglect all other sources. Find out the current. Okay, that is case 1. Then source 2, neglect the other source 1 and find out the current IB. Okay, then you sum up IB1 plus IB2, that will be your actual current. Okay, that is the meaning of superposition theorem. Now you people understood, Yashwant? You wanted me to explain again, Yashwant?
Ma'am, this theorem is only applicable when the source is when resistor is connected in parallel to all the source. Source in linear.
You ask your doubt again, Tanishka. I am not able to understand what you are asking me.
Ma'am, do this theorem is only applicable when the sources are connected in parallel to the resistor in which we have to find the current.
No, not necessarily. It can be present anyway. Suppose if you are having a current source here, well and good. That is also a possibility. Okay, it's not necessary that all should be connected in parallel.
Okay, ma'am.
Okay, Tanish?
Yes, ma'am.
Okay. All understood the theorem, superposition theorem? Yes or no?
Yes, ma'am.
Ma'am.
So what will you do for superposition theorem? Suppose if you are being given one circuit where there are so many sources and you are being asked to find out the current through a particular branch or a voltage across that particular branch, then what will you do? You have been asked to apply superposition theorem. So what will you do?
Neglect all remaining sources.
Consider only one source at a time. Okay, consider only one source at a time by neglecting all the others. Then you find out the current or the voltage across that branch. Then second case, you consider the source number 2 and neglect all the other sources, find out the current or voltage. Then finally you sum up all the individual cases, that will be the current actual. Okay.
Yes, ma'am.
Okay, now we will solve this problem again. So you have been asked to find out the current in 23 ohm resistor by using superposition theorem, and you know there is a voltage source and a current source there. So case number 1, I am considering only voltage source. So what is the other source that I have to neglect?
Current source.
Current source.
Current source. So whenever there is a current source means neglecting means you have to short it or open.
Open, ma'am.
Open. So this you have to open. You open this. Okay, and redraw the circuit and find out the current through 23 ohm. Understood the first step?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, I want to consider only 200 volt. So I have to eliminate this. This is a current source. So whenever I want to kill the current source, I am killing the current source means I will open. So I will open this terminal, that's all. And I will read out the circuit. Okay, you can see for yourselves that branch is open. So I am not having any current source here. So now I will find out the current through 23 ohm. Using current division rule only I will apply. So this branches I am interchanging in order to make analysis simple. So this 200 in series with 47 ohm I am bringing it here and 27 I am bringing it here. So the circuit will be redrawn like that. Now it's easy for me to apply the current division. Okay. So tell me what will be the total current? Total current?
3 ampere. 3.3 ampere.
First thing is you need to find out the total resistance. No, so how will you find out the total resistance?
Total is 23
See,
and 4.
these 4 ohm and 23 ohm, how they are connected?
Series
Series. So if you are summing, the equivalent resistance will be 27.
27.
The 27 and 27, how is it being connected?
Parallel.
Parallel, ma'am.
Parallel. So 27 into 27
13.5.
divided by 27 plus 27. Then that is connected in what manner with 47?
Series.
Series.
Parallel.
That will come in series. Okay, that is how this total resistance that is found to be equivalent to what value?
60.5 ohms.
60.5. Now you have found out R Thevenin. Okay. Now total current you need to find out. The given voltage source is 200 volt. The corresponding equivalent resistance is 60.5. So we can find out. Sorry, this is V. So total current is 200 divided by 60.5. So what is the total current that you are having?
3.3.
3.306. Okay. Now I have found out the total current. By current division, I can apply and I can find out the current through 23 ohm resistance. So what will be the formula? I23 is what I want. So total current into what is the value of the opposite resistance?
47, ma'am.
One total current. This is the resistance that I am considering. 23 ohm resistance. Opposite to that, what resistance is present?
27.
27. So 27 divided by 27 plus 27. Okay. So what will be I23? You are getting 1.653. All the others also, if you know the answer, you could give me the answer rather than simply solving and not telling anything.
One 1.65.
All got 1.653.
Yes.
Yes, ma'am.
Yes, ma'am.
Ma'am, I have one doubt.
Gaurav, what?
Ma'am, how the voltage
What?
source,
Yashwant?
ma'am, how the voltage source came to left side in this second circuit?
I will just interchange only. No, if I interchange same node connection only, so I can do interchange
Okay,
now.
okay.
You are asking how I interchange these two
Yes,
branches
ma'am.
only,
Yes,
no?
ma'am.
They are connected same node combination only. No, after that only there is a 4 ohm, so it will not be a problem if I am interchanging. The
Okay.
circuit originality is not changed, no?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay, in between, if you are having another element means then there will be a problem. But here
Uh,
no such elements are there. All are connected to the same node, no? So I can interchange the branch connection. It will
okay.
make my work easy only now.
Yes, ma'am.
Okay. So
Thank you,
this is
ma'am.
case number 1. Okay, case number 1 where you have considered what? Source alone?
Voltage source.
Voltage source, ma'am.
Voltage source. Now case number 2 where you need to consider the current source and you have to neglect the voltage source. Okay. So current source, we will move back to the previous circuit. That way it will be easy for explanation. Second case, in the same circuit, I will consider only voltage source
Current.
alone. Sorry, current source alone. So what will I do with the current? Sorry, voltage source. When it comes to voltage
Neglect,
source
ma'am.
killing, I need to short it. Okay.
Short
So I
circuit.
will short this. Okay. Then I will find out again the current through 23 ohm by some methodology. That is how I got the circuit. Okay, here I was having one voltage source that I have shorted. In place of the voltage circuit, there is a short. Okay. Now again, these two resistances were connected in what manner?
Parallel.
Parallel.
Parallel. So the parallel equivalent is 27 into 47 divided by 27 plus 47. What value does it give as answer? 17.2 ah?
$17.14.
Okay, good.
17.1.
That is answer. We can see to the next circuit, that's 17.2. Okay. Now again, I am interchanging this branch and this branch because all are in the same node combination. So I am interchanging, bringing it 20 ohm beginning and the other two elements in this side. Okay. Now it will be easy for me to calculate the current through I-23 again. Okay. So again, what is the total current here? By current division only I am doing it. So what is the total current? Total current is 20 ampere. So that IT is 20 ampere. The opposite value of resistance to this is what?
21.14.
17.2 plus 4. Okay.
21.2.
Divided by the sum of the resistance, that is 21.2 plus 23. IT is this current. So what is the value of IL again? I through 23 ohm.
9.58.
What is the answer? 9.6 they have given.
0.58 ampere.
You are telling the final answer, ah?
Yes, ma'am. Ma'am, it will be 9.6 only by approximation.
Okay, so this is for case 2 where you have consider only current source. For case 1 where you consider voltage source, the current through 23 was 1.653. So both you have to sum, okay, as per law of superposition. That will be your actual I-23. Okay, so what is the value that you have got? Because you are summing the final two results individual cases, this theorem is called a superposition theorem. What is the final answer if you are summing these two currents?
11.2, ma'am.
11.2.
7 point. Now people
11.2,
understood
ma'am.
what is superposition theorem? You understood, huh?
Yes, ma'am.
Yes.
Yes, ma'am.
Ma'am.
Okay, now we'll go to the second problem. So what is being asked in this problem?
Find the current in R3 in the circuit by superposition theorem.
Yes, find the current through R3. So this R3 resistance is 1 ohm through which you are supposed to find out the current by again applying what law or what theorem? Superposition theorem. So if you carefully observe the circuit, what are the various sources that are present in the circuit and how many? They have indicated the entering currents and leaving currents, no? What are the entering currents and what are the leaving currents?
20
20
Entering
ampere is
current
20
is 1
ampere
ampere.
and
entering,
15 and
5 and
5 is
15.
Entering
current
current is
is
20
15.
ampere, okay, and leaving currents are 15 ampere and 5
5
ampere,
5
ampere.
ampere.
okay. So if you want to analyze the circuit, you can consider it as two cases, okay. So the 20 ampere current, it when it comes here, it becomes 15, here it becomes 5 ampere, yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
first case 1, you can consider 15 ohm entering and leaving, okay, only. So you can neglect the other 5 ohm and you have to solve, okay. Case 2, you should consider only 5 ampere current entering where you will be neglecting 15 ampere current. Understood? All understood, huh?
No, ma'am.
Okay, if you are observing, there is a 20 ampere current that is entering, which leaves here at 5 and here it leaves us 15 ampere. So if you want to solve the circuit by superposition, Veerabhadan, mute your mic. Okay, if you want to solve this circuit, then you can do it in two cases. Okay. Case number 1, where the current is entering here as 15 ampere. That let us assume as first case, only 15 ampere. While you are going to eliminate this 5 ampere case. Okay. Case 2 is you are going to consider this 5 ampere only, but you are going to eliminate this 15 ampere lead. Okay, then you have to redraw the circuit and you have to find out the current through R3 individually, and then you will finally sum it up. Okay, let's see how it goes in the problem. That way you will be able to better understand. So first case I am considering what alone?
Negative 5 ampere.
15 ma'am.
15. Okay, then that 5 ampere I have to open because it is current element, so I will be opening, so it will be neglected. Okay, that is how it goes. And I am redrawing the circuit. Okay, now this 1 ohm resistance is obtained here between AC terminal. Now what about the other combinations? These two are connected in what manner and these two are connected in what manner?
3 are in series and
These are in series, so here you will be having 8 ohm. These two are in series, so here you will be
Series.
having 8 ohm.
8
So
ohm.
these two 8 ohms are connected in what manner?
Parallel.
Parallel. So 8 into 8 divided by 8 plus 8. What is the answer that you will
4.
be getting? 4.
4.
So that
64
4
plus
is
16.
obtained here. Okay? Understood how that
Yes,
equivalent
ma'am.
circuit came?
yes, ma'am.
Okay, now applying current division only. Okay, I want to find out the current through this 1 ohm R3. So by applying current division, I want to find out I1 ohm, that is equivalent to what is the total current?
15 ampere.
15 ampere. What is opposite value of the resistance?
4.
4. Then sum of the resistance is 4 plus 1. So what is the final current?
12
This is
ampere.
by case number 1 where you are considering only 15 ampere. What is the answer? 12,
12.
12
12
ampere.
ampere. Okay. Now understood first case, sir?
Yes, ma'am.
Okay. Now second case you need to consider what current alone?
5
Amperes.
5 ampere. Okay, the second circuit 5 ampere alone is considered here. And it is leaving over here. While the current here that is considered, again it is opened. Okay, so it is neglected. This is case number 2. Again you have to do network reduction and current division only. So if you want to reduce the network, how you can do that? These two resistances are connected in what manner again? 8.
Series.
So 8 into 1 divided by 8 plus 1. So what is answer?
0.88.
0.88. Okay. Then 0.88
We have
plus
to find.
here you are having, if you are reducing it is 0.88. Then how
Yes,
is
ma'am.
these connected? How are they connected? That 6 ohm and 0.88.
Parallel.
Parallel. I have reduced all these things. Then I have found out the equivalent. Okay, Ashant. Again I am telling you. These two were in 3 ohm and 5 ohm were in series. So I have reduced that 8. But 8 and 1 ohm is connected in parallel. So I have reduced that.
Yes,
That
ma'am.
will be 0.88. So and I am redrawing the circuit means 0.88 is in what way connection with 6 ohm. That is
ma'am.
series.
Sorry. Yes,
Okay,
ma'am.
series. So if I redraw the circuit, I will be having 2 ohm and the parallel combination will be what? 6.88. And the current here is 5 ampere, 5 ampere. Again by current division, I have to obtain the current through, sorry, this is 1 ohm,
2
no?
ohm.
1 ohm. This one is 1 ohm. 1 ohm or 2 ohm? 2 ohm, I think.
Ma'am, 2 ohm only.
Okay, how they have found out the current? Let me see. Okay. How they have found out the current here? Again by using current division. What is resistance value? Sorry, what is the I through 2 ohm current 3.88 you are getting, huh?
Yes, ma'am.
Yes, ma'am.
Then what is I through that 6.88?
1.8.
This current is 3.88. If I want to find out the current flowing here, total current is 5. So I through 6.9 is 5 minus 3.88. So the current will be 1.12. Okay, that they deleted here. Okay, but I want the current through 1 ohm only. Okay, for that little redraw and reduction they have made. Let's move back to the circuit. How they got 8, I will check it out. So again, this is that 1 ohm. And this is that 8 ohm. They have drawn it parallel, I think so. 8 ohm. And what about this one, this equivalent? Current through that 6 ohm, what value they have found out?
1.12, ma'am.
Okay. See the circuit now. I'm hoping you understood. Okay. So the earlier thing that we were doing is only I through 2 ohm you have got, but the thing is you need to find out I through 1 ohm. So slightly they have redrawn the circuits. The equivalent combination between 5 and 3 is what value? This is that 1
12,
ohm.
ma'am.
So here we are
12.
having 8 ohm. What? 12. 8, 5 plus 3, no.
Yes, ma'am. Yes, ma'am.
Okay. Yes, 5 plus 3. Then, yes, that these two is in parallel combination with that 1 ohm. Okay, if you find out that equivalent, that will be, I think, that way they have did it like that. Okay. 8 into 1 divided by 8 plus 1, no? So what is the equivalent that they've got? Parallel combination. That way they have drawn. That is how the circuit came up. See, if you connect this in parallel, okay, then it will be a parallel combination. 8 into 1 divided by 8 plus 1. So what was the value that you got? That is 6.9 only, no? Sorry, not 6.9. What's the value? 0.9. 0.9, no. 0.9. That is in series combination with that 6 ohm, isn't it? That way only you have reduced that earlier equivalent. Yes or no?
Yes, ma'am. 6.88.
Yes, that way only they have drawn the circuit. Okay, and again by okay, that way only they have drawn that circuit, and again how they have found out the current through this 1 ohm resistance that is being required to sum it up with the earlier value. So how they have found out here? Tell me. The total current is how much?
1.12.
1.12, and the opposite value of resistance is what?
8, ma'am.
8, and the sum of the resistance is 9. So 1 ampere current they have given. So by this way the current through that 1 ampere is 1 ampere current. The earlier case when we are considering 15 ampere, what was the current? I through 1 ohm, that was 12 ampere. So they have summed up and they have got 13 ampere. Okay. So this is as per superposition principle. Understood? Yes or no?
Yes, ma'am.
What about the
Yes, ma'am.
rest? Okay. See this earlier circuit that gives current through only 2 ohm, but you want to know current through 1 ohm. That's why they have proceeded with one more step. Okay, that's all. All right.
Yes, ma'am.
Oh, all right. Okay. So we'll discuss the maximum power transfer theorem and I will finish off. Okay. One more formula regarding maximum power transfer theorem I have to tell. Wait, let me load that maximum power transfer theorem. Try to solve extra problems. Okay, solving extra problems will make you better only. Will you do it or not? The more problems you solve, the more better you become. See, when I was teaching in the maximum power transfer theorem lab, I told you that under one condition only maximum power will be delivered to the load from the source side. At what condition?
Resistance is maximum.
Yes, when the resistance is not maximum, when the RL value is equivalent to R Thevenin. Okay, under that condition only, I will use a different color. So whenever that RL value becomes equivalent to R Thevenin, then only maximum power will be delivered from the source to the load side. That theorem is called as maximum power transfer theorem. So using that theorem also you can do circuit analysis. Plus there is a formula for finding out maximum maximum power that I will tell you today. That is P max is equivalent to V Thevenin square divided by 4L. So here also you need to find out what is V Thevenin, you need to find out R Thevenin, because that will help you finding out maximum power that is transferred. So what is being asked in this problem, tell me? The circuit shown in the figure observes maximum power, compute the value of R and maximum power they have asked. Okay, so they have asked you what is the value of this load resistance and what is the maximum power that has been transferred to this from the load source side they have asked. So as usual procedure, here also you need to find out V Thevenin and R Thevenin. That R Thevenin will be equivalent to RL, because they say it is consuming maximum power, and the formula for P max is given by a standard formula V Thevenin square divided by 4R Thevenin. Okay, that way we will try to solve the problem, but two unknown parameters are there. What are the two unknown parameters? R Thevenin and V Thevenin you need to find out. So you know how to proceed with finding out V Thevenin. So how will you find out V Thevenin? VOC or V Thevenin, how will you proceed? You will open or short that particular terminal?
Open.
Open. So this terminal is in question, so you will open it. And you need to find out V Thevenin or VOC across it. Okay, that is what you are going to do. Okay, this is the corresponding circuit where they have opened A, B, that is the terminal in question, and they have found out V Thevenin in what manner? Tell me. There is what source in the circuit? What nature of source?
Current
What
source.
nature of source? Current source. How much is the value?
20 ampere.
20 ampere. So if you follow up the current, 20 ampere, no? It gets divided like this, isn't it?
Yes, ma'am.
Okay. So they are assuming equal division of currents, or any other way also you can solve the problem. So any other possibility of solving the problem could you think of?
Current division theorem.
You can do source transformation. If you do source transformation, then what will happen? 20 ampere is a source, so I is equivalent to 20 ampere. The resistance is equal to 5 ohms. So what will be the voltage?
50 minus 50.
What is the value?
50 minus 50.
Voltage is 50.
You said resistance 5, current 10, ma'am.
That will be 100 volt, no? V is equal to IR is the formula.
Yes, ma'am. Yes, ma'am.
So current is 20 and the resistance is 5, so it will be 100 volt representation. So if you are redrawing the circuit, what will be the circuit that will be having now? This will be my 100 volt, and here I will have my 5 ohm, that is in series with the 2 ohm. So both, if I am summing, I will be getting 7 ohm. Then here I am having 3 ohm. Okay. So now if I am able to find out the voltage across this 3 ohm, I will be getting VOC is equal to VThevenin. So I can apply KVL in this loop and find out what is the current. That current I can multiply with this 3 ohm and I can find out VOC. That is another method. So do that method and tell me what will be the answer that I will be getting. It will be 7 plus 3, 10i, no, 10i is equal to 100. So I is equivalent to how much? Am I getting 30 volt there? What is answer, ma? I am applying KVL here. So V is equal to 100 volt. That will be equivalent to, I think, 7 plus 3i. So in this way, if I am finding I, 100 divided by 10, that will be 10 ampere current. That I will multiply with 3 ohm resistance. So VAB will be equivalent to 3 into 10. That is 30 volt. Okay, that is my VOC or VThevenin. This is another way of finding out VThevenin. Understood, everybody?
Yes, ma'am.
That I have obtained by what technique? By simple source transformation and KVL. Okay. Here they have solved it different way. They have assumed equal division of currents and they have proceeded because that is 2 ohm, 3 ohm, 5 ohm. No. Here these two combination of resistances. 5 ohm combination, they are equal. So they have divided the currents equally and they have found out what is voltage across 3 ohm. That is also equivalent to 30 volt. Either way you can solve. Okay, whichever way find it easy. Now after finding VThevenin, then what is the next thing that you need to do?
RThevenin.
RThevenin. So how will you find out RThevenin? What is the procedure for finding out RThevenin?
Kill.
Yes, you have to kill the sources. So only one source is there. Okay, we will disconnect this. Okay.
Current
Then
open.
you will. It is the current source. So what will you do?
Open, ma'am.
Open and redraw the circuit again. So this is the circuit. Then you need to find out RThevenin by looking back. So how will you do that? These two will be connected in series because it is completely open. So 5 plus 2. Then that is in parallel combination with 3. So what will be the answer for RThevenin?
One,
3
ma'am.
divided by some place. What is the answer?
2.1, ma'am. 2.1.
2.1. Okay, 2.1 is the answer. Alright. So now you know what is VThevenin. Now you know what is your RThevenin. Tell me what is your P max and what is your R value. Just now I told you the formula for doing it, no?
VThevenin square by 4 RL.
The value of RL is equal to RThevenin. Under that condition only maximum power will be delivered from source to the load side. So RL will be equivalent to RThevenin will be equivalent to 2.1 ohm. That is one thing that is being asked in the problem that is solved. Next thing is you need to calculate what is the P max value that is given by standard formula. What is the standard formula?
V Thevenin square upon
VThevenin squared
V
by
Thevenin
4
square divided by
RThevenin.
4 R
4
Thevenin. So what is
RThevenin.
V Thevenin is 30 square divided by 4 into 2.1. So what is your P max value?
107.1.
107.1.
One answer. That is correct only. Okay, this is how we will solve circuits by what is the name of the theorem?
Maximum power theorem. Maximum power
Maximum power
transition.
transfer. You have got the answer, one answer. Okay. One more problem we'll solve, after that we'll end up the class. So in this question, what is being asked? Read the question and tell me.
Ma'am, we have to
Linson.
find R-Thevenin, maximum R-Thevenin for power.
Yes, RL value, and as usual maximum power they have asked for the circuit, again by applying maximum power transfer theorem. So what do you need to do to proceed? Like last problem only. Here also first step is you need to find out VThevenin, then you need to find out RThevenin, then substitute these two things in the given formula, you will get both the answers. So how will you find VThevenin? VThevenin. So this is the terminal in question. So that terminal you have to disconnect. You have to open.
Shut.
Okay, not shut.
Open. Open.
Open on. Oh, Thevenin serum. No? Okay, and you will read
Okay,
raw.
ma'am. Okay.
Okay, and you will read raw like this. Now I am supposed to find out the voltage across this VOC. So I can do calculation this way or this way I can do. Okay. But still I don't know the current. So how will I find out the current? Current, all are connected in series. Once you open that in between terminal, all are connected in series. So what is I? By KVL equation only, no. What is the voltage source that are present in the circuit? There are two voltage sources which are valued at 12.5 and 1.7. So you will be, the signs are also different, no?
Yes, ma'am.
Here it is going from minus to plus. Here it is going from plus to minus if you circulate the current. So you will be getting 12.5 minus 1.7
Minus 1.7.
divided by, all the resistances are connected in series because you have removed the in-between terminal. So 0.4 plus 1.2 plus 0.6 plus 1.4 plus, what is the other resistance? 1 na? This resistance 1 plus 1. So if you do that, you will be getting current. What is the value of the current that you are getting?
120.
1.8. Okay. So since you have found out current is 1.8. So just you can observe the voltage across this, you will be getting VOC. So what is the voltage source that you present here? 12.5 minus all the voltage drops. So what will be the voltage drops? 1.2 plus 0.4 plus 1.4 into that current 1.8. So what is the answer?
Five points.
5 point?
I don't understand.
Don't understand, Veeravardhan, you did not understand. Which part you did not understand?
I too have not understood.
VThevenin, ma'am. After finding current, ma'am.
Okay, this terminal is opened, no?
Yes,
Here
ma'am.
only I want to find out VOC. Okay.
Okay, ma'am. Okay,
So
ma'am.
I can do it in two ways. Okay, either I can observe the voltage drop across this. That will be equivalent to VOC. Or other way around, if I calculate the voltage drop across this, okay, that will also be
Yes,
equivalent
ma'am.
to VOC. Either way I can do.
Yes, ma'am.
Okay, I am trying to do this way. Okay,
Yes,
so
ma'am.
what is the voltage source that is present? Voltage rise element.
12.5, ma'am.
Voltage rise element is 12.5. What are the
Yes,
voltage
ma'am.
drop elements? Voltage drop elements. There is a 1.2, there is a 1.4, there is a 0.4 across which all voltage will drop. Okay,
Yes,
so
ma'am.
1.2 plus 1.4 plus 0.4 into the current that I have determined. What is the current value? 1.8.
8.
What is the answer? Now you understood, everybody?
Okay, ma'am.
7.1.
What, Karthik?
7.1.
7.1, ma'am.
Sony understood, You're about to ask me something.
Okay, ma'am. Okay.
All understood, Amma? Shall I proceed?
Yes, ma'am.
Yes, ma'am.
What is the current, what is the voltage that you are getting for VAB?
7.1, ma'am.
7.1.
Yes, sir.
Here they have
Negative.
solved it by this method. Understood? Here they have solved it by other way.
Yes, ma'am.
Okay. Either way you will get the same answer only, 7.1. Okay? So V17 is over. Next what do you need to find?
R7.
Thevenin, ma'am.
Next thing, VOC you found out. Then next thing is you need to find out R-Thevenin. So what do you need to do for R-Thevenin?
Voltage short, ma'am.
You have to kill the sources. Two voltage sources are involved. Yes, both the
Short
sources
the
you will short.
circuit.
This source you will short and this source you will short. And you will disconnect this. Okay. And then you will be finding out R-Thevenin by looking back. Okay, let us see how they have did. So how it is being proceeded, tell me.
1.4 and 0.6 are series, and one
Yes, here all are connected in
series.
series. The sum equivalent will be 3 ohm. Here also all are connected in series. Again, sum will be equivalent to 3 ohm. Both are connected in parallel. Okay, so 3 ohm into 3 ohm. So what is the answer?
3 by
1.5.
1.5. Okay. Now tell me what will be your RL value and what is your P max? This resistance they have asked you what is RL. So it is equivalent to what value?
R7.
R-Thevenin. So what is R-Thevenin? 1.5 ohm.
1.5
So what will be P max? What is the formula for
1
finding out P max?
Thevenin square.
V Thevenin square by 4 R Thevenin.
For RL, R-Thevenin. So what is V Thevenin that you have found out? That 7.1 whole square divided by 4 into 1.5. So what is my P max value? Calculate and tell me. What about the newcomers? All are able to grasp and adapt? Which is Linson.
Nine 9.11 something.
9.1.
1.
Let me check. 8.4 they have given answer.
18.9, ma'am.
What value you are giving? 8.4, what is the answer, no?
No, ma'am. 18.9.
7.1 the whole square divided by 4 into 1.5. How all are telling different answers?
I'm 8.4.
8.4 only, no?
ma'am.
Yes,
Why
ma'am.
people are telling wrong answer?
Yes, ma'am. 8.4.
You did some
8.4.
wrong substitution. Okay, 8.4 watts. Okay, that is the answer.
Yes, ma'am.
Okay, ma?
Yes, ma'am.
Yes, ma'am.
Okay, now if people understood all the theorems well, what are the 4 theorems that we have discussed so far?
Norton's theorem, superposition, maximum.
Maximum power theorem.
Thevenin's theorem,
Norton's
Newton's
theorem,
theorem,
Thevenin's
superposition
theorem.
theorem, superposition transition.
One more maximum power transfer theorem. 4 theorems are included in your syllabus. Okay. So whenever it comes to solve a particular circuit, you can go for Ohm's law, KVL, KCL, current division, voltage division, network reduction, then all these theorems that we have seen, that is Thevenin's theorem, Norton's theorem, maximum power and superposition. By applying any method, you can obtain the circuit analysis. Okay?
Yes, ma'am.
Understood so far? See, and one more
Yes,
thing I
ma'am.
wanted to tell you. Do you know what is the voltage current relationship for RLC? For R, what is the relationship between voltage and current?
Yes, ma'am. It is V is equal
That is
to
given by
I
Ohm's
into
law,
Z.
no?
I into Z na impedance.
Okay, so VI for R resistance, V is equal to IR, that is given by Ohm's law. This is the relationship that is relating voltage and current for resistance element. Okay, that is well known to you. Suppose in the other hand, if you want to relate V and I for L, then what is the relationship? Do you know or you don't know? This might be asked in MCQs. Have you heard of the formula E is equal to L di by dt?
Yes, ma'am.
Ma'am.
In
Yes, ma'am.
physics class?
Yes, ma'am.
Minus L into di by dt.
Minus.
So this is current, this is voltage. So this is the voltage current relationship for what parameter?
Inductance. Inductance. ma'am.
Inductor.
Inductance. If you want to write I means what will you do? 1 divided by L into E dt.
Yes, ma'am.
Okay, this is another way of writing voltage current relationship for what parameter again?
Inductor.
Inductance.
Inductance. Okay, same way one more. V and I for capacitance. How will you write? This also you know, I think so.
C into
I
ma'am.
is
C
equal to C
into
dV by dt.
dt.
V is equal to 1 by C into I dt. So this is how you can relate V and I for what element?
Capacitor.
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 Capacitor. Okay, these questions might be asked in MCQs, very simple answer only. For resistance, Ohm's law. For capacitance and inductance, these equations. Okay. One is based upon electric field and the other one is based upon magnetic field relationship. With this, we'll wind up the class. I am hoping all understood so far, whatever things I have taught you. Yes or no?
Ma'am.
Yes, ma'am.
Will you please
Okay.
share this?
Yes,
So, in case if you are having any doubts, you ask. Otherwise, all are free to leave now. All can discuss.
Attendance. ma'am.
Thank you.
Okay, ma'am. Thank you.
Ma'am, and I have one doubt.
Okay.
Thank you, ma'am.
What?
Ma'am, during examinations, can we use calculators?
Yes, you can use basic versions of calculators which are not of engineering category. Okay. It should not be engineering science. Mathematical science calculator you can use.
Okay. Ma'am, so not that scientific ones.
Advanced versions are capable. Engineering E letter will be there, no. With the E letter, ES, that you cannot use. When you go for final year class and all, I think you can use. But for lower, first year, second year and all, in maths you will be calculating that matrix and all. So they won't allow engineering science calculator.
Okay, ma'am.
Only MS version it is allowed. Okay.
Okay, ma'am.
You want me to pass on the list of allowable calculators to you?
Okay, ma'am. Okay, ma'am.
That
That
I
will be
will do
great,
it later
ma'am.
because when it comes to writing university only, it's necessary.
Okay, ma'am.
ES it is not allowed. MS you can use. Okay.
Okay, ma'am.
Mm.
All can
Ma'am,
leave.
and will you please share this video also?
Oh, every day, whichever class I'm taking, I will share everything.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay.
Thank you, ma'am.